Hi there. Hi guys. Just give it a minute for other people.
Good morning.
Tommy, are you able to see the modules now, the reading material stuff?
Yeah, I was about to check now, so give me 1 second.
Yeah, let me know. I apologize, guys. What one of your classmates figured out this morning, I had thought, this is my first semester using Canvas, I had thought that the reading material module was published. I had published a bunch of individual stuff on the reading material. I thought it was all available for you, but it wasn't. Apparently, some parts of it were not being published, which meant that you didn't have access to it. You didn't see it. So thank you for your patience on all that. It's I'm getting used to Canvas as my first semester using it. So all of that solutions to the homework are now available. The whole reading material module should be published and available so that you can see all the background information for the class. Okay. Also, our quiz today is going to be made available at 12 o'clock at noon. It'll be a 24-hour availability window. So from noon today until noon tomorrow, you're free to start it at any time. So if you want to finish the homework problems, check your answers, and then you can upload your homework problems, and then you can start your quiz later. You can do it tomorrow morning. It's all up to you, as long as it's done before noon tomorrow. Okay. The quiz is a PDF up on the page, so that when you log in, when it's available and you start it, you should open up the PDF. You can print it out if you want to and work on that page that comes out as the printout. If you don't want to print it out, you can load it up on your screen and write the questions down on a piece of paper and then work them through. Totally fine. Just make sure that your name is on the page that you're working on. Okay. So that I can identify you in case things get weird with Canvas. I can see your name on it. What else too? If for some reason the quiz isn't available at noon today, send me an email right away so that I can get on and check it out and find out what's going on. It should be there. I can't think about anything else. Yeah, make sure that you, when you are done with your quiz, you've got 30 minutes to take the quiz. The department is allowing 15 minutes of time for you to take a picture or scan it in and upload that file, a PDF, please, to our Canvas page. If for whatever reason you think that upload is not working or you're not sure, send me an email with your attachment, your quiz attachment, and then we'll figure out what's going on. Okay, try to get that to work. Yeah, I'm trying to think about anything else too. Yes, you're free to use calculators. You probably won't need them. Please don't talk to other people about how to solve the quiz. This is a quiz to see what you know. We're basically using the honor system, okay, so that I'm going to trust you not to be cheating. Now, yes, you're free, you can take a look at, your notes or whatever it is that you're working with, but please don't talk to other people, and, please don't look up the solutions online either, or use some kind of like a solution solver to help you do that. Okay. What I'd like to do is I want to talk about chapter 1.4 today. 1.4 is not on the quiz, but it's 1.4. When I work through problems from 1.4, we have our lecture examples for 1.4. It's called the cross product. And then depending on how we're doing on time, we can break from 1.4 at some point, and then I can stop the lecture, stop things, and then I can answer questions on the classwork pages for 1.1, 1.2. I can answer questions about the homework problems for 1.1, 1.2 if you guys have them. So feel free, we can think about that. Let me bring up the chat window here. We can do that towards the end. So let's go ahead and get started. So this is chapter 1.4. So 1.4 is called the cross product. Now, when we were talking about vectors and vector math, things that we can processes that we can do on a vector. So if you make sure this is still in focus. Oh, why did it do that? No, my camera is not focusing. Let me put my pen there. All right, good. Okay, so when we talked about vector math properties, things that we can do, add, subtract, we did scalar multiplication. When we multiply two vectors together, we can either do the dot product. Now remember, with the dot product, we take in two vectors and we get a scalar as an output. With the cross product, we take in two vectors and we get a vector as an output. So in the cross product, we're dealing with vectors that are three-dimensional. Okay, so my vector v, v1, v2, v3. My vector w, for example, w1, w2, w3. Three-dimensional vectors, okay, to do the cross product. So let's talk about what we have. We're going to take as input, we take in two vectors. These are three-dimensional vectors, okay? The output that we get out of the cross product, which is different than the dot product, the output that we get is one vector. And that's also in a three-dimensional vector. So we take in two vectors and we get out one vector, okay, out of here. The important thing about this output vector is this output vector is perpendicular to each of the input vectors. Okay, so we tend to think of it, it's easier if when I'm in class, but if you can take a look at the screen. So I've got my two vectors, right? My W and my V. We tend to think of them like this, or what we call our right-hand rule. So I've got my W and my V. The output vector that we have is my thumb, okay? That basically is going to be normal to both of these. Okay, so I'm going to cross V cross W, and I'm going to get a vector that's normal to each of these. So it's kind of like if I draw it out like this. So I've got V and W as my input vectors. The output vector that I get.
Normal and orthogonal are the same thing, right? It's perpendicular.
Yeah, right. Perpendicular is so important that we have like a whole bunch of words that mean the same thing. Orthogonal and normal and perpendicular and right angles, they all mean the same thing. So we're going to write it like this. This is perpendicular. It equals perpendicular, which is equal to normal, which is equal to orthogonal, which is equal to right angles. Okay, it's such an important concept that we have a whole bunch of words that mean the same thing. Perpendicular, normal, orthogonal. I'm going to use all those terms interchangeably. Okay, normal I'll probably end up using more than others. Okay, so we have our output vector. We have our two input vectors, V and W, and my output vector is at right angles to, it's normal. Call it N for normal. It's my output vector. It's a normal vector. It's perpendicular to both the V and W. Okay. So remember, difference, dot product, take in two vectors, and I get out a scalar. Okay, scalar is just a number, right? Cross product, I take in two vectors. Okay, now cross product, the vectors are in three dimensions, whereas the dot product, I can take in any dimension vector that I want and get out a scalar. Okay, but with the cross product, I'm taking in vectors that are three-dimensional. Okay, and I'm getting out one vector that's perpendicular to both of these input vectors. Okay. Now, one of the things to know, we're going to talk about why this is in a minute, but one of the things to know is if our two input vectors are parallel to each other, right? So here's B, here's W, right? They're parallel to each other. Then our cross product is equal to 0. It'll be a 0 vector. It'll be like 0, 0, 0 will be our result. Okay, so like with the dot product was equal to 0 when the two vectors were at right angles to each other. The cross product will be equal to 0 when the two vectors are parallel to each other. So important things to keep in mind. How we denote the cross product looks like this. rewrite it like this. I say V cross W. It looks like an X, but it's kind of a slightly smaller X. And I'll say that's equal to N. Okay, so V cross W equals N. And as we talk along, we're going to talk about different properties. So V cross W is not the same thing as W cross V. We'll talk about that in a little bit. Okay. Give you guys a minute to finish writing this, and then we're going to actually talk about some background information. Where does this whole process of the cross product come from? Okay, you guys all set? I'm going to scroll up a little bit here. Okay, so just some background. This is going to help us actually do the whole process of the cross product. So some background. So some background info on the procedure for our cross product. The procedure for the cross product comes from a procedure in linear algebra that's called the determinant. We're really only just ever so slightly going to be touching on the concept of the determinant in this course. We'll get to that later in a later section, but really there's a lot that we're pulling from linear algebra that we're not going into a great detail, and we're just pulling the bits and pieces out that are going to be applicable to what we're trying to do for game design. So, but I just want to talk about how we actually calculate the determinant, because we use that process to calculate the cross product. So let's say I have a matrix A. Now I'm just going to call it A. Now a matrix itself is, those are all the coefficients from a system of equations. So one column is all the coefficients for my X variables, one column is all the coefficients for my Y variables, and so on and so forth. So when I say I've got A, B, C, D, these are all just numbers, okay? I'm just going to call them letters for now, just to represent it, but these are all just numbers, okay? So when I talk about the determinant of A, it's like I'm going to say, I put this, it looks like an absolute value, A, B, C, D. Okay, so I make these, instead of this is how I denote my matrix, but to take the determinant, I use just straight lines. It looks like an absolute value, but I'm putting it around this group of 4 numbers here. To actually go ahead and do the determinant, I'm going to multiply along the diagonal. So I'm going to multiply A times D, and then I'm going to subtract it by B times C. So I'm looking at things along the diagonal. So I'm going to go A times D minus B times C. And that gives me the determinant. It'll be a number, okay, because I'm multiplying these two. And I could get a negative number, I could get a 0. It's all going to depend on the exact numbers that we have. Now notice on here, I've got 4 elements. I've got 2 rows, and I've got 2 columns. So this is what we call a 2 by 2 matrix. Don't worry, this doesn't make sense too much, because we're going to go into a lot of detail about matrices in chapter 2. Okay, so this is our 2 by 2. Now I'm going to extend this. Let's leave that there like this. I'm going to extend this to talking about a 3 by 3 matrix, which is what we're going to use in our cross product. Let's say if A is equal to, let's call it A, B, C, D, E, F, G, H, I. So this is what we call 3 by 3. 3 rows and 3 columns. Okay, so these matrices have to be square. So I've got a 3 by 3 matrix. Now, if I want to take the determinant of A, right, I'm going to do the same kind of thing that I did before. I can take the determinant of any square matrix. Okay. Now, what happens is in linear algebra, and I encourage you to consider taking a linear algebra class. I can take any kind of row or column as a basis for my determinant. But we're going to focus on what we call a first row expansion. These are all linear algebra terms. Don't worry about remembering them, because when we do our cross product, that's the method that we're going to be using. So when I go to take the determinant of A, I'm going to take my first row, first column, my A, and I'm going to remember, here's first row, first column. I'm going to ignore those pieces, and I'm going to build up a little mini matrix of what's left over. Okay. Tricky part, I have to subtract B. There's a reason why I'm subtracting. I'm not going to go into it. It comes from linear algebra. I'm going to subtract B. This is first row, second column. I ignore those, and I build up a matrix of what's left over. DG, FI. Then I add C times first row, third column. I ignore those terms, and I build up a little mini matrix, a 2 by 2, of what's left over. Okay. And so now what happens is I'm going to take the determinant of these little pieces here. So I'm going to multiply along the diagonal here, multiply along the diagonal, multiply along the diagonal, multiply along the diagonal. So I'm going to end up A times, this will be EI minus GF. Don't worry about memorizing this whole, like, what all these letters are. We're gonna work through this process so much that you're gonna know the process. It'll be B times the diagonal, EI minus GF, multiplying on the diagonals, plus C times, multiplying diagonals, DH minus GE. Okay, and that will give me a determinant for my matrix. Okay, I'm going to go through an example. Our example 1 actually works through a 3 by 3 matrix so that you can see how this all works with numbers. Okay, and then we're going to pull it out, and then we're going to work it with our vectors, because the cross product is based on this technique. Okay.
Why'd you subtract B and add C?
Yeah, you asked me about that. So it comes from linear algebra theory. I wasn't going to go into it. For all we need to know, we just have to remember we have to subtract this. But what happens is these all have positions. This is first row, first column. This is first row, second column, first row, third column, right? So all these have positions. So this is second row, first column. You can see how this is going, right? This is third row, first column, third row, second column, third row, third column. So they all have numbers, right? So what happens is this subtraction comes from these things. They oscillate with a -1 raised to the row column added together. So this would be 1 plus 2. So -1 raised to the third power is equal to -1. And that's where that -1 comes from.
See.
Whereas this one, this is a -1 raised to the first row, first column, which is -1 raised to the second, which is just +1. So that's why there's a positive, and that's why this is a positive too. It's a linear algebra theory that we're just not going into. So what you need to remember is it's addition, subtraction, addition. But it comes from its position and how we calculate the determinant.
But it would basically keep the pattern. Like if they had a fourth variable, that would also be negative.
Right, right. So if you were to do a determinant based on, like the first column expansion, I'd have A times D times G, and then I'd have to be adding out, like, each one of these has like a positive and a negative coefficient depending on like its position in the matrix. So that's where that comes from. But it's like more in linear algebra theory that, and we're just not getting into that part. But it does have a reason. Okay. All right, so let's go ahead. On example 1, I'm going to calculate this determinant here, and we're going to do it just like we did with the ABCDs, but we're going to do it with numbers now. Okay, so I'm going to do a first row expansion, right, which means I'm going to say 2 times. So first row, first column, I ignore those, and I build up a matrix of what's left over, 1, 6. And I always write this out like this so I can keep track. 3 times, this is first row, second column, I ignore those terms, and I build up a matrix of what's left over. Plus 5 times, so first row, third column, I ignore those terms, and I build up a matrix of what's left over. Okay, my first step. Now I'm going to take the little mini determinants of what's inside here. So remember, we're going to multiply across on our diagonals. That's where our cross product comes from, right? We're crisscrossing our diagonals. Okay, so now I'm going to go 2 times, this will be 6 times 0 minus 4 times 1. Minus 3 times, this will be 6 times a -1 minus 7 times 4. Plus 5 times, this will be -1 times 1 minus 7 times 0. Okay. Multiplying on the diagonals, that's where I got these numbers from. Let's do that. So that's 0 minus 4 minus 6 minus 28 minus 1 minus 0. This becomes 2 times a minus 4 minus 3 times minus 34 plus 5 times a minus 1. Okay, so multiply through now. So this is going to be minus 8, negative times a negative. So minus 3 times minus 34 becomes positive 102. That's 0. 102 minus 5. Then I just add these up. Minus 8 plus 102 minus 5 is going to give me 89. And so a determinant, that's where our cross product comes from, the procedure. The determinant gives us a number. Okay, we're going to use it in chapter 2. We're going to come back to it. The cross product, when we do it, we're going to get a vector. We're going to see why in just a minute. Give you guys a second to finish writing that before I turn the page. Everybody okay with this? I'm going to move the page away. Okay. So now let's use our idea, our process for calculating the determinant for doing our cross product. It's going to look similar, okay, but because we're taking in two vectors, so I've got v, v1, v2, v3, and w, w1, w2, w3 is my two input vectors, and I want to have a vector as an output, okay? So what's going to look like this? If I do v cross w, okay? Order is important, so let's keep that in mind. Now, I need to set up my, it has to be a 3 by 3 matrix. And also, in order to get a vector as an output, my first row has to be my unit basis vector. Let me write that down. This right here are our unit basis vectors. Remember, I is equal to 1, 0, 0. J is equal to 0, 1, 0. And K is equal to 0, 0, 1. They stand for our X, our Y, and our Z positions, okay? Now, order is important. So V cross W, so V comes first. So V1, V2, V3, first row. Right? My W, oops, sorry, W1, W2, W3. W comes second. It's V cross W, sorry. V cross W, so W comes second. If this was a W cross V, then W would be in the first line, okay, and then V would be there. Okay. We're going to set that up. Now, when I go to calculate the cross product, I'm going to say the same thing that I did before, only I have I, J, and K to deal with. So I'm going to say I times, I've got first row, first column. I ignore those terms and I build up V2, V3, W2, W3. Okay. Minus J, first row, second column. I ignore those terms. V1, W1, V3, W3. Plus K, first row, third column. I ignore those terms and I build up a matrix of what's left over. Okay. Now we do like we did with the determinant. Okay, so I'm going to get my basis vector I times, right, I'm going to do multiply on the along the diagonals. Okay. It's going to look like this. V2 times W3 minus V3 times W2. Don't worry about memorizing all these little letters and subscripts and stuff. It's the process that we want to remember. Minus J. So I'm going to multiply along the diagonals. V1 W3 minus V3 W1 plus K. V1 W2 minus V2 W1. Okay. And then remember, right, in the end, right, something multiplied by I gives me my x coordinate of a vector. Something multiplied by j gives me my y coordinate of a vector. Something multiplied by k gives me my z coordinate of a vector. So the result is a vector. Okay, so I can write this in vector form. Like this. V2 W3 minus V3 W2. That's going to be a number. This is going to be negative, right? Because I have a negative j. V1 W3 minus V3 W1. Okay, comma. V1 W2 minus V2 W1. Please don't memorize this thing right here. Okay, you want to remember this and the process by which we generate it. Okay, don't torture yourself with trying to memorize V1 W2 whatever. Okay, you're going to remember this process here. Okay. We'll try an example on the cross product so we can see what it looks like. Give you guys a second to finish writing that. Okay, so I'm looking at example 2. So we're actually going to.
I'm sorry. Go back.
Yeah, go for it.
Why'd you put the little comma behind at the bottom? It's on the last equation.
Yeah, it's a coordinate. Now this is our normal vector, right? So when I multiply by I, I'm like saying this is my x coordinate of my vector. When I multiply by j, it's my y coordinate of a vector. When I multiply by k, it's my z coordinate of a vector. So it's our vector. So that's why this right here, this is our output, our normal vector. This number minus this number and this number. X, Y, and Z components.
Okay.
Okay, so let's do it with numbers. We'll do an actual cross product instead of just with letters here. So example 2, we're going to calculate the following cross product. We can think about this as our V and this is our W here. When I calculate that cross product, remember we set up our first row is always our basis vectors, because that's going to force our output into being a vector. This one crossed that one. So 3, 1, 2 goes in that row. Minus 5, 0, 4 goes in the bottom row, because that's the order that we specified for our cross product. Okay, so let's go ahead and set this up. So remember our first basis vector I times first row, first column. I build up a matrix of what's left over. Minus j, first row, second column. I ignore those terms and I build up a matrix of what's left over. Plus k. First row, third column, I ignore them and I build up a matrix of what's left over. Okay. Now we're going to multiply on the diagonals, multiply on the diagonals, multiply on the diagonals. Okay. Go ahead and do that. So I'm going to say I times, this is going to be 1 times 4 minus 0 times 2. There's a times. Minus j. 3 times 4 minus, watch your negatives, minus 5 times 2. Plus k. This is going to be 3 times 0 minus 5 times 1. Okay, so watch your negatives. Right? It's just negative times a negative, negative times a negative when we go to do it out. This is going to be I. This is going to be 4 minus 0 minus j. This is going to be 12 minus a minus, so plus 10. Plus k, this is going to be 0 minus a minus, so plus 5. Okay, so watch your negatives. Okay, we're subtracting, so that's going to negate whatever that term is right here. Okay, so this is going to be I times 4 minus j times 22 plus k times 5. Okay. Now I can put that in as just a vector. We'll say my normal vector. My normal vector will be 4. Watch this. This is a negative j, so this becomes minus 22, positive 5. Okay. We take in two vectors and we get a vector that's normal to both of those. Okay. So I'm going to call your attention to this. Comes from here. Don't forget the negative. It's a common mistake when people are first learning this. Are you guys good on this page here? Right. So, like we did with vector addition, there's a parallelogram rule for cross products. Let's talk about what that looks like. This is like geometry for cross product. When I say parallelogram rule, it's really just a way of kind of drawing out our vectors here and how to think about it. So I've got my vectors. I've got V and W, okay, and they're separated by an angle theta. This is my vector. Okay, when I go to do the cross product, I'm going to cross V cross W, right? And I'm going to get a vector that's normal to both of those two, right? So remember how we drew this out? I get the vector that's normal to both of those two. So now, with my parallelogram rule, you can imagine I have a vector that's parallel to W, and I have a vector that's parallel to V. So it creates a parallelogram. Now, for these, right, for a parallelogram, so I'll do this in a different way. My parallelogram, I'm going to think about at the height of a parallelogram, okay? So now the height of the parallelogram is important because it's going to help me calculate stuff like the area of the parallelogram, the area of the triangle, and all that. Okay, so now when I think about the height of my parallelogram, right, I want to know what it is. So I have to think about, right, I've got this angle, theta, okay? And what I have is, remember our trig functions, right? So opposite, my height is opposite. And I also have, this is a right angle, so this here is going to be the hypotenuse. Right? So if I say, if I'm going to reference my height, I'm going to say my height is equal to the opposite side, right? Let's actually, wait, I'm thinking about this. So my sine of theta is equal to the opposite, which is the height, over the hypotenuse, which it's a vector, but I want the magnitude of that because the vector, if I need to reduce it down to like a length, the length is what I want. So I'm going to take the magnitude of that side. So the sine of theta, let's see, this is sine of theta, is equal to the opposite over the hypotenuse. Okay, so my sine of theta is equal to, sorry, I wrote this out wrong. Let me write this better. Sine of theta is equal to the height, right, opposite over the hypotenuse, the magnitude of W. So to solve for the height, my parallelogram, I just multiply. So that's the magnitude of W times the sine of theta. That gives me the height of my parallelogram. Why do I care about the height? I do because if I multiply height times base, that'll give me the area. Okay, the base of my parallelogram is the magnitude of V, right? So now I can get the area of our parallelogram by substituting in for height. So magnitude of W, magnitude of V times the sine of theta. And that gives me the area of my parallelogram. Where this comes in handy though, mostly, is on my parallelogram, I've got these two vectors. You can imagine I'm going to make a triangle out of them. I've got W and V, and if I connect them this way, I have a triangle. That red line that I just created cuts my parallelogram into half, okay? It cuts it, here's a triangle here, here's a triangle here, okay? So remember, our area of triangles is 1/2 base times height. Okay, so now what I have is, right, I've got base times height of my parallelogram, and I just divide it by 2. So the area of my triangle that's spanned by both vectors, v and w, is 1/2 magnitude of w times the magnitude of v times the sine of the angle between them. Okay. And these are important. We tend to ask these questions later on, okay, as we go. So what you don't know is the area, right? We just came up with the area of our parallelogram, and that's equal to the magnitude of the cross product of these two. Right, so I don't have to actually draw out the whole parallelogram and figure out what's the sine of theta and all that. I can just take the cross product of v and w and calculate the magnitude of that cross product, and it will give me the area of that parallelogram, okay? If I cut that magnitude of the cross product in half, I'll get the area of the triangle that's spanned by both of these vectors, okay? Now I can use this magnitude of the cross product to figure out the angle between these two, the two vectors, v and w. So if I say that, oops, sorry. If I say v cross w magnitude.
Is that theta?
That is theta. Yes.
Okay,
thank you.
Sorry.
Yeah, I know. Sometimes my pen doesn't work. Sine of theta. Right. So if I want to solve for theta, I'm going to divide by the magnitudes. Then I'm going to get sine of theta equals magnitude of the cross product divided by the individual magnitudes. Or you can't see that. Now, if I want to solve for theta, I have to take the inverse sine. So then my theta is equal to the inverse sine. That's a button on my calculator. Inverse sine of magnitude of the cross product divided by individual magnitudes. And this gives me the angle between the two vectors. Okay, so it gives me the angle between the two vectors.
What's the it's right next to the formula. Is that a 1?
Where are you looking?
It's right under the word angle. And is that a 1?
Right under the word angle, right here.
No,
Oh, this
yeah,
was this was a scratch. I made a mistake. And I
Oh,
tried
okay,
to cross
okay.
it out. Okay, so I've got an angle. I can calculate the angle between them. Okay. So remember, this is the area. Oh, this is the area of the triangle. So here's W. Here's V. We would normally make a parallelogram out of them, right? But I've got this. That's the triangle. Then here's theta. Okay, so that area is equal to 1/2 base times height, which is 1/2 magnitude of W times magnitude of V times the sine of theta, which is also equal to 1/2 the magnitude of their cross product. Okay, I don't have to go through the whole thing of calculating out the sine of theta and all that. I can just calculate the cross product, take its magnitude, cut it in half. That'll give me the area of the triangle of which W and V form two sides. Okay. All right. Let's do this. why don't I do, we'll do this example 3, and then we'll stop, and then I can answer questions about stuff if you want to prepare for the quiz. Okay, so example 3, we've got the our last example. Okay, so V is 312, W is minus 504. We want to check the orthogonality of the last example. So we said that the cross product was perpendicular to each of these. Okay, so the first thing that we're going to do is I want to check to make sure that, let's remind ourselves. So we calculated V cross W, that was 4 minus 22 and 5. Okay, so if it's really true that the cross product, which is our normal vector, is going to be perpendicular to each one of these, that means I can use the dot product to prove that. So if that's true, then I can say N, which is my cross product, dot V should be equal to 0. And N dot W should be equal to 0. If we did the cross product correctly, this is a check for orthogonality, right? So I'm going to take my N, which is 4 minus 22, 5. I'm going to take the dot product with V, 3, 1, 2. Let's see what we get. This is going to be 4 times 3 plus, remember we're multiplying corresponding components and adding them up. Minus 22 times 1 plus 5 times 2. So this is 12 minus 22 plus 10. 22 minus 22 is equal to 0. Check. My dot product is equal to 0. That means that N is orthogonal, is normal to V.
Why'd you do V times N?
When I do what?
Why'd you do N times V?
And we were told to. So it said check the orthogonality of it. So orthogonality means, are these vectors perpendicular to each other? So we made this claim where we said that the cross product vector, the vector that we get as a result of taking the cross product, is normal to each individual vector. So that's what I'm checking right now.
Oh, you took the normal vector and multiplied it times each
right, yeah.
Okay.
So this is my cross product, and I said that was equal to N, right? So now what I'm going to do is I'm going to take N dot product with each individual component, because if the dot product is equal to 0, then we know that those two vectors are perpendicular. Okay. So I did that with V, it's perpendicular. We're going to do it with W. So I'm going to go N, 4 minus 22, 5, dot product with W, minus 5, 0, 4. Let's see what we get. Corresponding components, first times first. Okay, so I'm looking at minus 20 plus 0 plus 20, and that's equal to 0. So my dot product for N dot W is also equal to 0. So I can then conclude that my cross product is perpendicular to each individual component, which is what we said. I told you that this is true, but now we've just shown it. We did the quick check. Okay. So part B says, calculate the area of the parallelogram spanned by V and W. So we've got V and W, so I'm going to write it out. I'm going to draw it like this. So here's V, here's W, and I'll draw my theta. Here's my parallelogram. So now I have to calculate out my height, right? Which I'll call this H. So now let's see. There's a couple things I have to do. So I have to find the area parallelogram. We said was the magnitude of the cross product. Okay. So that means that I can take the magnitude of N. I can take the magnitude of 4 minus 22, 5. Remember, our magnitude calculation is I take each individual component and I square it, sum it up, and take the square root. So my magnitude's always going to be positive. Okay, right? So make sure you're careful about your order of operations. This is in parentheses minus 22 quantity squared, so the negative goes away. And then when I get this out, I get 525 inside of a radical, which you can leave like this, or you can recognize that it's 25 times 21. I can take out the 25 from my radical. You leave it in terms of radicals. If you don't know how to simplify, just leave it like that. It's fine. Okay. So this is the area of the parallelogram. So that's this whole thing.
Can you go back to that again?
Yeah, you bet.
Yeah.
Okay, so part C says, we want to find out what's the angle between V and W. We're going to use the cross product to figure that out. So let's remember that our cross product definition is this. I can take the magnitude of my cross product, V cross W, and that's equal to the magnitude of W times the magnitude of V times sine of theta. So, and theta is the angle between my two vectors, okay? So this we just calculated here in part B. Okay, so this is going to be 5 radical 21. That's my magnitude of my cross product. I have to figure out what's the magnitude of V and the magnitude of W. So I'm going to do that offline. So W magnitude. So if I calculate the magnitude of W, I have to square each individual piece, each component, sum them up and take the square root. 25 plus 0 plus 16, I'm going to get radical 41. I'm going to leave it in terms of radicals. Do the same thing for V. I'm going to square each component, 3 squared, plus 1 squared, plus 2 squared, sum them all up and take the square root. So 9 plus 1 plus 4, that's going to give me a radical 14. Okay, magnitude of W, magnitude of V. So let's plug in our pieces. So magnitude of W, radical 41, times magnitude of V, radical 14, times the sine of theta. Okay, my goal is to solve for theta. So I'm going to start by dividing out by my magnitudes. Okay, so I'm going to get 5 radical 21 all over radical 41 times radical 14 is the sine of theta. To solve for theta, I have to take the inverse sine of both sides. I take the inverse sine of this, 5 radical 21 all over radical 41 times radical 14. I take the inverse sine of sine, I just get theta. Okay, now watch, be careful what you're doing because I'm taking the inverse sine, not the sine. So when I go to do the inverse sine, I do it like this. I say, what mode am I in? I'm in, we'll do for student degrees so we can see. So I'm going to take, see my, sorry, you can't see that. My inverse sine is this blue button here. I go second blue, my inverse sine. Now, I get it like this. I have to be very careful with my order of operations. So I'm going to go parentheses 5, radical 21. Okay, and that's going to be, watch when I have to get rid of my radical, that's going to be divided by parentheses radical 41 outside my radical times radical 14 outside my radical, close parentheses on that, and then I have to close the parentheses on the sine. Okay, so I'm really kind of going overboard on my sine functions. Oops, okay. So I did that all in one fell swoop. Okay, you can do that in multiple pieces where you calculate out this piece right here and then take the inverse sine of whatever that decimal is. Okay, so if you want to do that, that's fine. I did it all in one piece. So when I did this, I get theta equals 73.01 degrees, which if I did it in radian mode, I would get 1.274 radians. I'll take both as answers, but just make sure you tell me your units. Okay. That tells me the angle between these two. Okay, so what I'd like to do actually is I'd like to stop here because there's some other stuff that that we're going to be using the cross product for. We've got some other concepts that I want to cover, but I don't want to be rushed for it. So I'll stop here for chapter 1.4. We'll pick it up on Monday, including we'll then use it as a launching pad to talk about 1.5. Okay, and then we'll do some practice problems on all of these things here. But I'll leave this here for 1.4, and then we'll spend the next 15 minutes. I can answer questions. We can go over classwork problems for 1.1, 1.2. I can answer homework problems. Or if you guys don't have any questions at all, then we can end class at this point here. Okay, so it's going to be up to you.
I have question on like the question number 5 on the homework.
Sure, let me get my homework problems out. Give me just a second.
Okay, sure.
You guys all good with this? I'm gonna move it so I can do homework stuff.
I just like don't understand what you mean by 3 equally spaced point on the line. Like,
We're talking about homework, or are we still on this, or are we talking about homework?
We're talking about like homework number 5.
Homework problems. Okay, no problems. Give me a sec. All right, so question 5. So consider the line that goes through -1, -2 in the direction of 2, 3. Write a parametric equation for the line. Find 3 equally spaced points along the line. Okay, so let's do this. Get out my solutions. Okay, so so what I did, let's start this from the beginning. So this is homework. Actually, I'll do this in so question 5. Okay, so homework question 5. So we've got a line. The question is the line through -1, -2, and in the direction of 2, 3. So the line through, this is a way of saying a line through a point. Okay, so this is our point on the line. When we say it's in the direction of, this is another way of saying we have a vector that's going to be parallel to that line. So we have a point and we have a vector. And remember, for a vector equations, parametric equations, they're synonymous with one another. So my vector equation is x bar equals x naught plus t, my parameter, times v, my vector that's parallel to the line. So I'm going to put my point in here for the point, and I'll put my vector in for the vector. So my equation is going to be -1, -2 plus t times 2, 3. So that's actually the question for part A. Okay. So now what it wants is 3 equally spaced points on there. So what I'm going to do to go 3 equally spaced points, I'm going to choose my t values, right, my parameter values, so that they're equal distance apart. So I'll choose t equals 1, t equals 2, and t equals 3, just as an example. I could have chosen t equals 10, t equals 11, t equals 12. See, the difference between them is equal, right? So I'll choose my first point is going to be, so x1 is going to look like, I'm going to go -1, -2 plus t equals 1, 1 times 2, 3. So -1 plus 2 is equal to 1, -2 plus 3 is equal to 1. That's my first point. My next point is going to be -1, -2. See how I'm using my vector equation for the line. I'm substituting in t in order to get these points on here, plus my next t value, which is 2, times my vector. So this is -1, -2 plus 4, 6. And that point is going to be -1 plus 4 is 3. -2 plus 6 is 4. See how we're doing that? My next point, -1, -2, is going to be my t is going to equal 3 times my vector. minus 2 plus 3 times 2, 3 times 3. So minus 1 plus 6, 5, minus 2 plus 9, 7. You can see it in here. Look, I've gone 2 spaces between my x, 2 spaces between my x's. I've gone 3 spaces between my y's. Okay, and all I did was choose t values that were equally spaced apart. They were just consecutive t values. That makes sense?
Okay, I got it. Thank you.
Remember, our homework problems only go up to question 8. Those are the ones that I'm collecting this week by midnight tonight.
Oh, they only go up to question 8?
Yeah.
Oh my
'Cause
god.
were you doing them beyond? No wonder you're stressed out. So I'm only collecting
Oh my
problems
gosh.
that correspond to chapters 1.1 and 1.2. So homework problems that deal with chapter 1, because that's our quiz. Our quiz is on 1.1 and 1.2. So I only collect the homework problems up until
Okay.
I think question 8 is the one that goes. That's all we have. After that, then we go into 1.3, 1.4.
I
So
thought so. I thought I was crazy.
yeah, right. Like, why am I asking you for homework that has to do with like cross product or all sorts of
Yeah,
other
because
intersections
I was
too?
struggling with number 11. I was like, I definitely don't know how to do it.
Right, because we haven't learned it yet. Yeah, exactly.
Yeah.
That'll be next week. That'll be next time.
Okay.
Any other questions you guys want to ask about the homework
Yeah,
or classwork?
1 second.
Okay.
Yeah, so can you explain the number 2, the parallelogram law again?
Yeah. You mean the homework question number 2?
Yeah.
So question 2. Let me scroll this up here. Question 2. Okay, so question 2 says that A and B be vectors as follows. Draw the parallelogram law for the linear combination A minus B. Okay, so we're looking at, I'm trying to think, how do they have it? A and B. Okay, so we've got A and I've got B, right, as my two vectors here. Now, yeah, it's kind of a funny, we're kind of using, so the parallelogram law is like, right, I've got this additional, I can make a B that's parallel and an A that's parallel. So I didn't draw that very well. Here's B and here's A, right? So that's my parallelogram law. The thing that's important here, because we want to be able to illustrate A minus B, right, to do this. So to illustrate A minus B, how I want to think about it, I think what I'm going to do is I'm going to draw this so it's a little bit flatter so I can
Wait,
visualize
I'm
it.
sorry. Wait. So how'd you know to draw the A and B line in that direction? That's what I missed.
Like this?
Yeah,
Was that given to us like that, or did I just come up with it?
I think you just came up with it.
Did I just come up with, okay, I'm looking at my solution, so I'm not quite sure what's up on your questions. So if we're just going to illustrate A minus B, then okay, you can forget about that part, right? Okay, so if I can just draw it however I feel like, I'm going to draw it so that it looks like this. And they're not giving me values for A and B, right? If they're not giving me values for A and B, then I can draw it however I feel like to make it easy for me to conceptualize, right? So the parallelogram law says I've got a vector A that's parallel to this one, and I've got a vector B that's parallel to this one. So it makes up a parallelogram, okay? Now, in the parallelogram law, what happens is the diagonal is A plus B, okay? That's my diagonal of the parallelogram. Now we want to show A minus B. So what I need to do is A minus B is really
It's just the
A,
opposite, right?
yeah, A plus a minus B, right? So now if I'm going to do A plus a minus B, I wrote where I was just going to draw. So here's my A. I'm going to draw it again. Here's my B. Okay, so now a minus B is going to be in the opposite direction from where my current B is. So here's a minus B, okay? So now I get to draw another parallelogram like this. So I'm going to draw, here's my A, and then here's my minus B. So here's my A, here's my minus B, right? Now, if I go to add these two, it's going to happen in this direction, right? Because it's the diagonal. So this is going to be A plus a minus B, which is A minus B. Okay. And think about, here's our A plus B, right? It's that diagonal, that parallelogram. So if I make a minus B first, then I can make a parallelogram shape facing this direction. Like I've kind of flipped it. But how I chose to draw it is if they don't give me coordinates, if they don't give me like values for A and B, I'm not going to draw it in the coordinate plane. That means I'm free to draw it however I feel like. So I'm going to draw it in a way that's going to make the most sense for me to visualize.
Yeah.
What I did here.
Can you also go over question number 3 on the homework?
3? Sure thing.
Yep. Thank you.
Alrighty. Let me make sure you guys have this one. So I'll start down here so I can just scroll up. Okay, so question 3. Okay, so question 3 says, suppose an object travels in the xy plane at a constant velocity, -1, 2. At time t equals 0, the object is at position 3, 0. Okay, so part A says at t equals 2, what's the object's displacement from its initial position? And I can assume my initial position is the position at time t equals 0. So time t equals 0, we're at 3 naught, right? 3, 0. So I'm going to say my initial position is 3, 0, because that was my position at time t equals 0. Okay. Now I'm moving, right? T times v, right? So this is going to be t equals 2 times in this direction here, right? So 3, 0 plus 2 times -1, 2. This is going to be 3, 0 plus -2, 4, which is equal to 3 minus 2, that's 1, 0 plus 4. Okay. If you know about like velocity, right? Velocity is distance over time. So if I multiply velocity by time, I'm going to get distance. So you can kind of think about it like that, right? For part A. And for part B, B says at time t equals 2, what is the object's, oh, whoops, sorry, this is actually part B. Yeah, I answered B first, sorry. This is B, my bad. I answered B first, and this is A. So B, this is our position. Okay, and then we want to talk about displacement. I got ahead of myself. Displacement at time t equals 2. So I answered part B first. So part B was our position after we were displaced by this amount. Okay, at time t equals 2, we were at this final position at 1, 4. So our displacement at time t2 is basically t times v. We're being displaced by that amount, which is 2, which is like what we did here, -1, 2, -2, 4. So that's our displacement, which gives us a resultant position of 1, 4. I answered them in reverse. And when you guys are ready for that, I'll do part C. C and D. Let me know when you're ready for C and D. And then I have to quit. I have to let you go. Our math department has told us we have to be very good about letting you guys go right on time and not holding you over. You guys ready for me to do?
If you're okay with it, can you stay like extra like 10 minutes?
I actually can't. I actually have to go into my next thing, so
Okay.
I can't. But and I know we have issues with the office hours, but I can't do it because I've got something I have to be at. You guys ready for me to go to C and D?
Yeah.
Yeah, I'm ready.
Okay. Okay, great. So this is the same question. This is 3. Okay, so 3C says, suppose there was another object initially at 1, 1. It travels at a constant velocity, minus v, okay? Find its position at time t equals 2, okay? So now what happens is my initial position for this object is at 1, 1, okay? And then what I want to do is I'm traveling here. So that means that my v is originally, so if v is equal to minus 1 comma 2, minus v is equal to positive 1 negative 2. Okay, so that's how we want to think about this, right? So that means I'm going 1, 1 plus my time times 1 minus 2. So this is my equation that I'm using to describe the position for my second object. Okay, so at time t equals 2, I'm going to plug in t equals 2. I'm going to go 1, 1 plus 2 times 1 minus 2, which is 1, 1 plus 2 minus 4. 1 plus 2 is 3. 1 plus a minus 4 is minus 3. So that's the position for our second object at time t equals 2. Okay, I'm going to do part D really quick. So D says, what's the distance between them? Between the two objects. Remember, our object 1 ended up being at position 1, 4, and our object 2 is at position 3, minus 3. So I'm going to use my distance formula, which is a glorified Pythagorean theorem. Okay, which means I'm going to go, I'm going to take the difference between 1 and 3, so 1 minus 3 squared, or minus a minus 3 squared. Okay, it's like, you can imagine if I've got, so I go 1, 2, 3, 4, or so I get 3. So I've got 1, 4, and then 3, 3. So I'm looking at, what's my distance between these two here. So I'm using my Pythagorean theorem to come up with that. So this is going to be 2 squared, right? And then 7 squared, which is going to give me 7 squared square rooted, which is going to give me 49 plus 4, which is radical 53, and whatever like position or distance units we're using. Okay. You should have access to our reading material now too, the course notes and everything like that. You can look through those to give you extra information. I tried to do examples that were from that as well as from elsewhere, so that you can have sort of a, your lectures will be slightly different than just reading it out of the course notes. But the course notes also talks about distance between the two objects too, which is just really our Pythagorean theorem. It's the hypotenuse of our triangle. Okay. Okay, guys. Good luck. Don't forget to take a look to make sure that the quiz is available. If you have a hard time or if it's not available, let me know and I'll log in and then check it out to see what's going on. Okay.
I have a quick question on the quiz. So if we don't print out the quiz from Canvas, we have to write out the answer, the question, right?
Yeah, exactly. So like, you don't have to print it out at all. Just put your name at the top. So I'm going to, put my name at the top, right? And then this is going to be, I'm going to write down, keep yourself sane. So this is going to be quiz number 1, right? Question 1. And then what's the question? What's the question that's being asked? And then you're going to do all your work. Show me all your work so that you can get credit and partial credit. And then you're going to write down what's the question for question 2. And then you're going to do all your work and so on and so forth. And you're going to fill up however many pages, 1 page, half page, 2 pages, whatever. many pages you need. Okay, so you don't have to print it out at all, but it
And
will be helpful.
And you said we get 30 minutes?
And you have 30 minutes to take it. That's correct. And it's set up so that you could definitely do it within 30 minutes.
Okay.
And you have 15 minutes on top of the 30 minutes to take a picture of it, convert it to PDF, and then upload that PDF into the Canvas page. Okay.
Okay.
All right, you guys. Good luck. If Canvas is giving you a hard time, then send me. Try to do it. Try to get it to work. When in doubt, just send me an email with the quiz attachment, with your PDF attachment, and then we'll figure it out. Okay. But definitely try to upload that into Canvas. Okay, because that's where I'm going to be looking for things. Okay.
All right.
All right. Good luck on the quiz, and if I don't talk to you, have a great weekend then.
All right.
Okay. Bye, guys.